This video will cover Chapter 3, Section 5. This is on rational functions. So if you look at your list of parent functions, you should see the rational function 1 over x. 1 over x is the parent function. You should look at the shape of it because we're talking about rational functions. Everything we graph on here should have that similar shape. Alright, now when you look at rational functions, alright, you're talking about, you could have a polynomial on top and bottom, right? Polynomial in the numerator, polynomial in the denominator. Alright, so when we're looking at the degree of a polynomial, we're looking at the largest degree of any term of the polynomial. So whatever the largest degree is, alright, in that polynomial, the largest exponent, that's going to determine what the degree of the polynomial is. Alright, now when you're graphing and dealing with rational functions, we have to look at things called asymptotes. Alright, and to find asymptotes of a rational function, they are defined by a rational expression in lowest terms. So there are two types. There's the vertical asymptote. Remember, vertical is up and down. And then there's the horizontal asymptote, which is the flat, left and right. Alright, so to determine the vertical asymptote, what you're going to do is take the denominator, set it equal to 0, and solve for x. So if we look at, well, let's just go through this first. Alright, the number that x is equal to is the vertical asymptote. So it would be, let's say we solved and we got x is 5. We would go to where 5 is on the x-axis, and we would draw a vertical line, and that would be our asymptote. Alright. For horizontal asymptotes, there are a couple of things to look at. If the numerator has a lower degree than the denominator, then there's nothing to do except to say that the horizontal asymptote is at y equals 0, or the asymptote is the y-axis. Alright, if the numerator and the denominator have the same degree, then what we do is we simplify the first term of the numerator and denominator. You can see that here, a over n over b over n. And that's going to tell us the horizontal asymptote. Alright, so let's take a look at the very first. Let's take a look at this first function. Alright, it says for each rational function, find the vertical and horizontal asymptotes. Alright, so for the vertical asymptote, what we do is we're going to take the denominator and we're going to set it equal to 0 and solve for x. So I would add 3 to both sides to get x is 3. Alright, that would give me a vertical asymptote at x is 3. So I would go to 3 on the x-axis and draw me a vertical line. Alright, to find the horizontal asymptote, I look at the leading terms of the numerator and denominator. Alright, and so what I'm doing is looking for the degree. If I look at the leading term here, 2x, its degree is 1 because that's what the exponent is. And on the bottom, the degree of it is also 1 because that's the exponent of my leading term. So they have the same degree. So what I'm going to do to find my horizontal asymptote, and this is going to tell me where to draw my vertical line. I take the two terms, 2x over x, and I simplify them. Alright, the x's divide each other, and so 2 divided by 1 leaves 2. Alright, so I would have a vertical asymptote where x is 3, a horizontal asymptote where y is 2. Now, if you're planning on moving any further in math to calculus or whatever, you're definitely going to see these things again. Alright, so here's what we're going to do. For the next one, we're going to take the denominator, set it equal to 0 to find our vertical asymptotes. So we'll say 2x minus 1 equals 0. When we solve for x, we move the 1 over and divide by 2. Alright, and we have a vertical asymptote at x equals a half, but I still have another factor down here in my denominator. I set it also equal to 0. Subtract 3 from both sides and find that I have two vertical asymptotes. One at 1/2, one at -3. Alright, then when I look at, for the horizontal asymptote, alright, let's come up here and do this. Alright, if I multiply these two things out, 2x times x would be 2x squared. Then we'd have 6x minus x is 5x minus 3. So if I took these two things and multiplied them together, this is the actual polynomial. This is it in factored form. So if you plan on going into calculus, Cal 1 or higher, all right, you want to pay attention to this because you're going to need to remember how to factor. And it's going to come in handy in the very first section. All right, so anyway, we look at our leading terms here, the x and the 2x squared. All right, and so that's going to tell me, if I look at their degrees, the numerator has a lower degree than the denominator, so no need to simplify. I know automatically from my very first statement here that if they have the numerator has a lower degree than denominator, automatically my horizontal asymptote is at y equals 0. All right, so let's see, what does that mean exactly when we're talking about graphing? All right, so here we have a couple of functions. All right, and we're going to, let's see, first find the vertical asymptote, and then we're going to find at least 3 points on each side of the asymptote. So first of all, we look at, we take, for the vertical asymptote, we're going to take the denominator, which is x, and set it equal to 0. So what that means is our vertical asymptote is the y-axis, where x is 0. Alright, so that's here. So I'm going to draw me a dashed line like that. That's going to be my vertical asymptote. And then what I want to do is find at least 3 points on each side of that. So 3 points to the right, 3 points to the left. You can pick them however you like. Since it's at 0, I'm going to pick -1, -2, -3, and +1, +2, +3. Excuse me. Alright, then we can also look for a horizontal asymptote. Alright, and so I'm looking at the numerator and the degree of the numerator. Alright, there's no variable in the numerator, so its degree is 0, and down here it's 1. Alright, so the degree comes from the variable. Alright, so 0 and 1 are my degrees, and since the numerator has a lower degree, then I know that my horizontal asymptote is at y equals 0, which is simply the x-axis. So I'm going to draw me a dotted line like that. Alright, so when I graph my function, I should not cross the asymptotes. Alright, those are places where the value is, there's no, it doesn't give the function a solution. Alright, so what I'm going to do is take and fill in these values into my function, -1, -2, -3, 1, 2, 3. Alright, and let's see what we get. So if I have 3 over -1, that would be a -3. 3 over -2 is simply -3 halves. And 3 over -3 would be -1. Alright, so -3, -3 halves, and -1. And then the if I fill in 1, 2, 3, it should simply be the opposite. So +3, +3 halves, +1. Alright, then I'm going to graph those points. Alright, so let's see. -1, -3 is left 1, down 3. And then -2, -3 halves would be right 2 and down 1 1/2. So -3 halves is simply 3 halves. That would be 1 and another half. And then -3, -1 will be right 3, down 1. Alright, then we're going to graph the others. They tell me to go right 1 and up 3 right 2 and up 1.5, and then right 3, up 1. Alright, and if I've looked at my parent functions, I know that in a basic rational function 1 over x, what the graph should look like. Alright, so when I connect the dots, notice I'm going to get very, very close to my asymptotes, but I'm never going to cross them. Alright, especially on my vertical one, because that is what makes the denominator be 0 and my function undefined. Alright, so my graph should look like that. Okay, so let's take a look at the next function. It is 2x plus 1 over x minus 3. So to find my vertical asymptote, I say x minus 3 equals 0. When I solve for x, I get x equals 3. Alright, so I'm going to go to where x is 3 on my graph here. 3. And then I'm going to draw my asymptote. So I need a ruler to do that because I can't draw a straight line. Alright, so I'm going to... Alright, so there's my vertical asymptote at x equals 3. Alright, then for my horizontal asymptote, I'm going to look at the degree of the numerator and denominator. So the degree of the numerator is 1. The degree of the denominator also 1. So since they have the same degree, I take 2x over x, I simplify it, and it'll simplify to a 2. So that's y equals 2. So I'm going to go to where y is 2 on my graph, and I'm going to draw an additional asymptote. This is going to be my horizontal asymptote. Alright, now remember, this tells me where my function is undefined. Alright, here, the vertical one. And my graph should not cross these asymptotes. Alright, so what we're going to do is we're going to pick 3 values to the right of the vertical, 3 points to the left of the vertical. So our vertical asymptote was at 3. So 3 points to the right would be, let's see, it doesn't matter what they are. Let's see, 4, 5, 6 are 3 points to the right, 4, 5, 6. And then 3 points to the left would be 2, 1, and 0. Alright, so 4, 5, and 6 are 3 points to the right. 2, 1, 0 are 3 points to the left of my vertical asymptote. Then I'm simply going to fill those in to my function to find out what the y is. So if I fill in a 4, that would give me 9 over 1, which is 9. Alright, and then if I fill in a 5, that would give me 10 plus 1 over 2 is 11 over 2. Then if I fill in a 6, that would give me 13 over 3, 13 thirds. Alright, then, let's see if I can see what I'm doing here. And then I'm going to fill in a 2. So 2 times 2 plus 1 over 2 minus 3 would be 5 over negative 1, which is negative 5. Alright, then I'm going to say 2 times 1 plus 1 minus 3 would be 3 over negative 2, so that's negative 3 halves. And then for 0, that would be 1 over negative 3, or negative 1/3. Now, if you want to go through and pick values that'll give you something, whole numbers rather than fractions, that's perfectly fine. But remember, we're simply sketching a graph. We're not doing anything exact. Remember, you can also plug these values into your calculator. Alright, so let's go through and get our points here. Alright, so 4, 9, so I'm going to go to 4, and then somewhere up here is 9, and then 5 is 11 halves, or that's 2 going to 11 5 times. So